Welcome back, students. In part 6, we will learn about the third type of evidence that requires or needs geometric analysis and a work strategy. It's not that easy to find, but it will be after learning some of the strategies that we will be using later on. In this part, we will cover the following. First, we will learn about the transitive property, which is new. 2, we will remember some concepts like triangle angle sum, segment addition and subtraction, angle addition and subtraction, because we will use them later on. And last, we will solve exercises covering everything. First, let's start with the transitive property. The property says if A is equal to C and B is also equal to C, then obviously A is equal to B because they are both equal to C. Example, if A is equal to 2 and B is equal to 2, then A and B are both equal. In another meaning, two quantities that are equal to the same quantity are equal. Here when I say two quantities, it can be anything like length of two segments, like measure of two angles. If these two quantities are equal, like here, quantity A and quantity B are both equal to the same quantity C, that's why they are equal. Example 1. In this figure, segment AC is equal to segment CD. Here, the quantities are in fact length of segments. And segment BD is also equal to segment CD. That's why I placed the same code. Show that segment AC is equal to segment BD question mark. Here, it's obvious that these two segments are equal because they are both equal to the same segment quantity CD, but we cannot claim it before we prove it. And by looking at these two straightforward evidence given to us, they are similar to the transitive property that we just learned. The fact that segment AC and BD are both equal to the same segment, same quantity CD, that's why they are equal. So how do we write the proof? First, we write AC equals CD. It's straightforward evidence, so reason is given. Also, BD equals CD. It's also a straightforward evidence given. Result, AC equals BD because AC and BD are both equal to the same segment CD. So here we used the transitive property. So the reason here should be, we don't write transitive property, we just write by transitivity. So in case we use the transitive property to prove the equality of two segments or any other quantities, the reason that we write is by transitivity. So transitive property is used when we can prove that two quantities are equal to the same quantity. So if we want to prove that two quantities are equal and we already know that, or we can already prove that they are both equal to the same quantity, in this case we use the transitive property. Example 2, in this figure, angle XOY is equal to angle ZOT, and angle UOV is also equal to angle ZOT. Show that angle XOY is equal to angle UOV. Here also, same steps. We notice that both angles XOY and UOV are equal to the same angle TOZ. By transitivity, we can prove that they are equal. So proof, since angle XOY is equal to angle ZOT, the reason is given. And since angle UOV is also equal to angle ZOT, it's also given, result angle XOY is equal to angle UOV by transitivity, because we used the transitive property. So attention, in both example 1 and 2, no measurements of sides or angles were mentioned. So here, if we don't have any measurement, how are we going to prove the equality of these two segments or of these two angles? One of the methods is to use the transitive property in case the evidence given to us are enough to use this property. Remark, if the evidence mentioned in the exercises above were available, we use the transitive property. If in the exercise we have enough evidence about the fact that two quantities are equal to a same quantity, and we need to prove that these two quantities are equal, in this case we use the transitive property. Now let's continue with angle addition and subtraction. Observe this figure. In this figure we can name three angles, angle BAT and DAC, that are adjacent, and the third angle BAC that is equal to the sum of these two angles. In case they gave us the measure of this green angle and this orange angle, to find the measure of BAC, we add both angles. If they gave us the measure of the green angle and the big angle BAC, the red angle, to find the measure of the orange angle, we do the red angle minus the green angle. And if they gave us the measure of the orange angle and the whole angle, the red one, to find the measure of BAD, we do red angle minus orange angle. So let's write the equations, calculation equations. First, to find the red angle BAC, we do green angle BAD plus orange angle DAC. To find the measure of DAC, we do red angle BAC minus green angle BAD, angle subtraction. And to find or to calculate the measure of green angle BAD, we do red angle BAC minus orange angle DAC, angle subtraction. So to find or to calculate the whole angle, we do angles addition. To calculate a part of an angle, we do angle subtraction, because the green angle and the orange angle are two parts of this red angle. Let's continue with segment addition and subtraction. Observe this figure. In this figure we have segment AB is equal to 11 units. It can be anything, centimeters, meters, any given unit. Let's watch this animation. In this animation we see, however we move the point C, the segment AB is equal to AC plus CB. It's always 11 units. Now let's write the calculation equations. Segment AB plus segment CB is equal to segment AB. So AB is equal to AC plus CB, segment addition. Now if I want to calculate segment AC, from segment AB I need to remove the part or the segment CB. So AC is equal to AB minus CB, segment subtraction. Now if I want to calculate the segment CB, from segment AB I need to remove segment AC. So CB is equal to AB minus AC. The reason is segment subtraction. Now let's continue with triangle angle sum. Let's observe this figure. In this figure we have a triangle ABC we notice here that if we glue its three angles, the blue one, the green one, and the orange one, if we glue them next to each other, they will form a straight angle. That's why when we add the three angles in a triangle, their sum is always 180 degrees, as you see here. 90 plus 56 plus 34 equals 180 degrees. This is a right angle. Let's see if we change the shape of this triangle. However we rotate or we change the measure of its angles, you will notice here that the sum of the three angles will always remain 180 degrees. The three angles will always form together when we glue them a straight angle. Property: the sum of the three angles in a triangle is always 180 degrees. As you see in this figure, 100 degrees plus 45 degrees plus 35 degrees is equal to 180 degrees. Now let's write the calculation equations. In case I want to calculate angle BAC, the blue one, I do green 108 degrees minus green angle ABC plus orange angle BCA, and the reason I used triangle angle sum, because if I know the measure of two angles, to find the third one, I do their total sum minus the measure of the two known angles. If I want to calculate the orange angle BCA, I do 180 degrees minus the blue angle BAC plus the green angle ABC. Same reason, triangle angle sum. And last, if I want to calculate angle ABC, I do 108 degrees minus blue angle BAC plus orange angle BCA. Same reason, triangle angle sum. So here be careful, we are not using angle subtraction, because here we don't have two adjacent angles that form a whole big angle. No, here we are using the property of the triangle angle sum, which is a completely different property. So here be careful when you write the reason, it's not angle subtraction. Here the 108 degrees is not an angle, it's the sum of the three angles of a triangle. It's not a whole angle. So don't be confused between angle addition or angle subtraction and the triangle angle sum property. So this is the end of our video. In the next part, we are going to solve exercises related to the properties that we learned in this video. Thank you for watching.